Hi there. The purpose of this video is to explain the operation of a clamp meter to measure currents without directly breaking into a circuit where it's either high current or high voltage. So we use a clamp meter, which is a current transformer. What we've got here is an electrical convector heater at 230 volts. It's 750 watt rating. We would expect 3.3 amps out. 1250 watt rating, we expect 5.4 amps out. 2000 watts, we expect 8.7 amps out. So in the actual operation, we've got a clamp meter around here, which has got the neutral wire going through it. We've separated the cables out into single core so that we can get a single core going through the current transformer so that the magnetic fields don't cancel out, which we'll demonstrate later. So what we're going to do now is we're going to switch 750 on. 750, the prediction from Ohm's law, or the prediction from power, is 750 divided by 230 is 3.3 amps. We're measuring 3.0 amps out. If the voltage is varying, then the current will vary in proportion against Ohm's law. So 3 amps in the physical circuit, 3.3 at nominal 230 matches what we predict. If we switch 1250 on, the prediction was 5.4. We're measuring 4.9 amps coming out, a little bit lower than I expect. That may be because the voltage is a bit lower than 230. And if we do 2000 watts, we expect 8.7, and what we're measuring is 8.1 amp. So all three readings are consistently a little bit below what would we expect or predicted from 230 volts. So we can measure current, and we're measuring current without breaking into the circuit. So why have we got the single core cables coming out? Normally, double insulated cable for safety. We've taken out the single core so we can measure around each individual wire. We've got neutral at the moment. If we go and measure clamp round the brown live wire, we should measure the same current. Current through the brown live should be exactly the same as it is through the neutral. We're measuring 8.2 there. If we measure current through the earth cable, what would we expect? We would expect 0 amps because the earth cable does not carry any functional current. It's only there to provide fault current path. If we measure current around both the live and the neutral cables together, what do we get? We're measuring 0 amps coming out. There is a little bit flicking there to 0.1, which is a little bit surprising. We would expect that the current going through the neutral, the current going through the live are exactly the same. The magnetic fields around them cancel out so that we measure 0 current, which is what we expect out, because the magnetic fields cancel. Again, if we go back to individual wires, we go back to the brown live, we clamp it round the cable, and we're measuring 8.1 amps. So the cable going through the live and the cable going through the neutral are the same if there is no fault current. So this clamp meter is a current transformer. The core provides a single turn, and wrapped round that is a coil of multiple turns, which allows a current transformer to operate where you're picking up the magnetic field, and the instrument, the clamp meter, is translating that magnetic field into a current reading. Thank you for watching.